Hello, everyone, and welcome to the Tom's Hardware Podcast for October 20th, 2020. As always, I'm Tom's Hardware Editor-in-Chief, Abram Pelch. I'm joined by our regular expert, Ash Puckett, and Associate Editor, Les Pounder. And today we have two very special guests. We have Alex, the LowSpecGamer, to talk about Raspberry Pi gaming, but we have something really special. We have Jeff Geerling, who's been on the show before, but he's got an incredible scoop. He managed to have and do extensive testing on the new Raspberry Pi Compute Module 4, and he's actually got one in his hand, and his time is really limited. So we can't keep him too long. So if you've got any questions about the CM4, please, those of you who are watching live, put them in chat, and we'll see if we can get to them. But first of all, thank you so much, Jeff, for joining us today. What do you think of the Compute Module 4 overall?
Yeah, well, I'm glad to be here, and I don't want to take away anything from LowSpecGamer. I'm looking forward to what he has to say. I'll probably have to watch that later just because I have a meeting right after this. But the Compute Module 4 is, for me, it's really awesome because, and I have two models that the Raspberry Pi sent me. One of them has the eMMC, this one right here, and the other one doesn't. You might wonder, what's this orange tape? It's actually Kapton tape that I'm using to do some thermal imaging during some benchmarking I'm doing. Some more stuff is coming soon, so subscribe to my YouTube channel for that. But it was cool to see these things because I spent a lot of time this year with the Compute Module 3 Plus, and I've been using I've been using Raspberry Pi 4s for a lot of projects lately, and I got used to that speed. Going back to the Compute Module 3 Plus, which uses the same system on a chip as the Pi 3B Plus, you realize that every generation of Pi gets a lot better, but the Pi 3 Plus to the 4 was a huge difference. The CPU is twice as fast. You get a PCIe bus in the Compute Module that in the Pi 4, that's actually used by the USB 3 chip that gives you those two USB 3 ports. So I/O is faster. It has a built-in gigabit network chip, so you get gigabit networking and not like the hacky 250 megabits you got on the Pi 3B Plus and older if you used it through USB 2.0. Just all these little things that are way faster on the Pi 4, and all that now is in that Compute Module. And a lot of people might wonder, like, why would you use one of these? It doesn't have a USB port. There's no HDMI port. These are for embedded projects, industrial projects, things like that, where someone will design a board. This is the I/O board for development purposes that has all the ports on it. But you could put this into a TV and have a custom smart TV that runs Raspberry Pi OS or some other OS. You could put it into a little handheld console and have a portable virtual emulator. You could put it into a big sign on the side of a building and have it control that sign. There's just so many little things that you can do with it. And it's all powered by these two little connectors. They're 100-pin board-to-board connectors. And it's just a cool thing to build these different applications from. Having a complete, pretty fast Linux computer in this size can enable a lot of neat projects.
So you found, to me, this was the coolest thing that you found. You found that you were able to use an NVMe, or no, you used a SATA. You use an NVMe SSD, right? A PCIe NVMe SSD.
Yeah. So
natively.
So I first was trying with an XPG NVMe drive that I had, and I found that it wasn't working with any of I bought 3 different adapters, and this Compute Module development board comes with a PCIe 1X slot, which in the comments on my video, I don't build PCs anymore. The last time I did that was like 2003 or 2004. I do a lot of hardware stuff, but I don't do like a PC with graphics cards and things. So I didn't realize with PCIe slots, you can actually hacksaw or Dremel this little slot right here and put a larger card into the same interface, and it'll just run with 1x bandwidth. So I have some more tests that I'm going to do now that I know that fact. Thank you all the internet commenters who said the exact same thing. But basically, you can put any PCI device that is compatible with PCI Express, as long as it has drivers for Linux or has built-in support. And I have an adapter that you can plug any NVMe drive into this slot. And I found that this drive, the Samsung 970, works great. Probably most of the Samsungs would work. I don't know about other XPG cards, but that's one thing that's a little bit difficult because there's a lot of different standards with NVMe. That's upside down. A lot of different standards with NVMe. You have like NVMe that uses SSD or SATA mode or all these different things. So you kind of have to find which ones work with what devices. But the cool thing about it is that even if you use this exact same drive, if I use this in a USB 3 adapter on the Pi, I can get like 40 megabytes per second write speed for random writes. In the NVMe slot adapter, I can get 70 megabytes per second, and that's like double the speed of what you can get through a USB 3 connector. So it's neat to have that support built into the CM4. And what that makes me excited about is there was the Turing Pi that I did some videos on my YouTube channel, and the Turing Pi used Compute Module 3 pluses. Unfortunately, with this new form factor, it can't just slot in there and you can't start using it. So they're going to build a new Turing Pi and have built-in storage, and that storage will make it so much faster for the Kubernetes clusters that I build with my Raspberry Pis.
Wow, that's amazing. So you said you've had a couple of different adapters that you tried to get it working with PCIe.
Yeah, and what I found was that these adapters, like this is a very generic one. I don't even remember the company that makes this. But these adapters are basically just taking the lines and putting them into the NVMe drive. These cards are some of the simplest. You can see on the back of it, let's see if I can get the camera to focus. Probably not. There you go. It's just a few traces that go to the right pins on the slot. So the adapters are really simple. And I thought, oh, maybe my adapter's broken, but I found out that the actual drive, the XPG drive that I was using, must for some reason be incompatible, or its driver just doesn't work with the Pi's built-in support. But like I said, the Samsung worked fine, and both of them work in a USB 3 adapter. So this is a USB 3 adapter. Same thing. It's just it uses a USB 3 interface, this little chip. But like I said, the USB 3 speeds are a little slower than the speeds that I get native with NVMe support.
Wow. So that's definitely a big plus for somebody who just wants the most Pi performance when this comes out, which is going to be mid-November for the version with Wi-Fi. They should probably get this and the board. It's going to be it's obviously going to be more expensive than buying a regular Raspberry Pi 3 and just doing USB. Now we do have one comment/question I wanted to bring up, which is really would love if you could boot from the storage PCIe slot. So you said, I believe you said you can't.
Yes. So I tried booting every which way, and it's interesting. So if you use the Lite version, so if I put this Lite board on here, this micro SD slot is used. But if I put on the version that has eMMC, this slot is not even hardware identifiable on this board when you boot it up. So when you use the Lite module, it will search for a USB boot device or for a micro SD card, and it'll just keep flipping between the two. But it right now won't search for an NVMe drive attached to PCI storage. So you can plug in a USB 3 card here and have a USB 3 drive, an SSD or any kind of device, and it'll find that, but it won't find an NVMe drive plugged in there. I actually was asking a lot about that because I was like, I really want to do this. Please let me do this. And they said, well, that's not a priority yet, but hopefully after showing the speeds that you get with it, basically double the performance for random access, and seeing how tightly integrated, like imagine if you put a riser on this board and just had the card like this. That's a pretty small package that has a lot of power for a Raspberry Pi. Every time I do these benchmarks, I have to remind myself the Mac that I have sitting in front of me can do like 2 gigabytes per second, and the Pi is doing like 80 megabytes per second. So it is. It's still not like super amazing performance desktop class, but we're getting to the point with these Pis where I can do things and they run as fast as a cloud VPS, a low-end cloud VPS that I'm using for other jobs, like Jenkins that does my deployments and builds container images. So Raspberry Pis are getting more and more adept at those kind of things, the more speed we get out of them.
Yeah, that's just amazing. Well, I know you have a busy day, and we thank you for taking a few minutes out of it to show everybody and talk about the Compute Module 4. We'll let you go, but I just want to remind everybody to read Jeff's full review and watch the video. You can read his full review at jeffgeerling.com. Go to the blog there, or you can find it by searching for him on YouTube.
Yes. Yeah. Thank you so much for having me. I love the PyCast, and that first episode with Eben. This is kind of like the fulfillment of that episode where he talked about, yeah, we're going to expose that PCIe. So now we are exposing that PCIe. So
yeah, everybody's excited to see it, and you're the first to show it. So thanks so much. Great.
Yeah.
Great
thank you, everybody.
Thanks.
So that was exciting. I can't wait to try one of those and see what it will do. Not just for opening apps. Because I personally, my big pet peeve on any computer is app open times. I want my apps like my Chromium, even whatever, to open so fast that I can't even tell that I clicked it. That's my dream. It doesn't even really happen on a PC with SSDs all the time, but we could get so much closer with NVMe PCIe. So now I wanted to ask Alex about, now that you've seen the CM4, do you think that could have any impact on game emulation?
Well, I mean, I have been getting tweets almost all day of people sending me the image and wondering if this is something you could connect a GPU to. What Jeff commented about the fact that you can just like open a hole and connect a GPU or any PCIe card and it should work just with lower bandwidth is correct, and it's a thing that I have done on PCs and on other devices. I don't have an answer to all the people that have been tweeting at me. I imagine that with AMD GPUs and the open source drivers, some work will be done. It's definitely not just going to work out of the box. But it's a matter of time before someone actually figures out how to get it working, and then it's going to be an interesting experiment and an interesting use case to see what the heck you could do with a Raspberry Pi connected to an external GPU. It sounds weird. It sounds almost like a thing that science has gone too far and shouldn't allow. But I imagine it's going to be interesting once it happens.
So you've been spending a lot of time looking at what the cutting edge is for emulation, and there's a lot going on there. So can you talk about that? What are some of the new things that are happening with Raspberry Pi emulation?
So for the longest time, we have been limited mostly to like old retro console emulation. But thanks to the efforts of a project called Box86, an open source project, which is trying to create an emulation layer that allows execution of Linux x86 programs on a Raspberry Pi on ARM. Well, it's on a quantity of ARM boards, but a lot of it's focused on the Raspberry Pi. The project has seen a tremendous amount of success and even running certain games directly from Steam. Indie games like Shovel Knight or Teslagrad, or older games like or the Unreal Tournament, even like 3D stuff already. And it's something that is, I always have to have a little bit of care when talking about online, because it's super unstable and it's still early stages and it's advancing so fast that every time I make a video about it, I have issues trying to finalize the video and publish it, because between the time I finish the script and I publish the video, a new update has come out and most of the things I'm saying are no longer valid. So that's how fast it's evolving. But the beautiful thing about it is that with that progress, I have a lot of confidence that in the near future, There's going to be a very strong community of people playing retro PC games the same way people playing retro console games, especially with the results we're seeing right now, and especially for future models, either with more severe overclocking on the Raspberry Pi or with models that are more powerful. The tools are going to be there to do that. Now, the main limitation, I have been speaking a little bit with some people involved in some levels of the project. It is an open source project after all, and something that I have been told several times is that the main limiting factor, one of the main limiting factors right now is the OpenGL. It has to run through OpenGL. It's the only option there is, and OpenGL it's starting to show its age on many levels. However, there's a lot of progress being done on the Vulkan driver for Raspberry Pi. A few hours ago, I believe, there was a post on the Raspberry Pi blog talking about the progress that they have made. And honestly, the last time I was tracking this, they were like on first triangle, and they're already like passing most of the tests. It's still not ready. They're integrating it into Mesa. It's much closer to being like a stable thing that I expected it to be. And I know the people from Box 86 are just waiting for that to be a thing because they would just rather have the whole project emulating to Vulkan rather than using OpenGL. And the other neat part about it that absolutely blows my mind is that there's some people crazy enough that have managed to get this working with Wine. So Wine is an emulation layer, a compatibility layer rather. I'm not going to fall into that mistake again. It's a compatibility layer for running Windows programs on Linux. So if you get that working on Raspberry Pi, you have a Windows program running through Wine, running through Box 86, and then get it to the Raspberry Pi. There's like 2 layers of emulation there, which means the amount of opportunities for things to fail is enormous, and it shouldn't be working. And yes, yet it is. There's already old PC games like Sega Rally that are functioning surprisingly well on a Raspberry Pi through Wine. So if that's the results that we're getting right now on those early stages of that project, I have no doubt that this is something that is going to be very instrumental for the sort of gaming that people do on Raspberry Pi in the very near future. And add to that, I'm always a little bit careful of mentioning things that I haven't tested myself, but there's a lot of communities that have been making a surprising amount of progress in getting Windows for ARM working on Raspberry Pi. I remember when the Raspberry Pi 4 came out, there was an article, I believe it was yours, Avram, on testing Windows on Raspberry Pi, and it was like super early, like it barely worked.
Oh well, I did it on the 3, and then Les did one more recently on the 4 when it had been ported to the 4. The overall message, and I certainly invite people to go to Tom's Hardware and look at our running Windows 10 on Raspberry Pi article, our most recent one. But yeah, the performance is terrible. It's just an achievement that you can do it. I don't think we even managed to get Wi-Fi working. Is that right? We couldn't get Wi-Fi?
Well, we didn't get Wi-Fi working. No, it was terrible. And we've got Amir Dahan in the chat right now, who's the lead for that project. It was terrible, but there have been some great advancements since we wrote that one.
So we got to try it again. I mean, to be fair, to be fair, it's trying to do something that we're not supposed to, which is what I love. I absolutely love it when you do something just because you can, even if it's not officially supported. That's where the fun is, right? It's no fun just to do what you're allowed to do or supposed to do. Got to push it, right? So I really admire work like that, like the work Amir is doing. It's amazing that people are out there giving their time to that, and it would be really cool to get to a place where Windows 10, Windows on ARM ran as well on the Pi as it does on some of those Windows on ARM notebooks, which I have to say are not great, but are passable for things like web browsing. One thing that has happened to me as I've gotten more and more into the Pi over the last couple of years is it's given me a lot more respect and love for Linux because it's become kind of a gateway drug for Linux. Like I've used Linux before, but now that I'm using it all the time on the Pi, it's really like, hey man, I'm in Windows. Why can't I do an apt update to get to get some new packages. Where are my new packages? And my son, who's 8, he gets it. He's like going in there doing his pseudo stuff. So I think now, my 2 cents, I really wish that all versions of Linux, all flavors of Linux were as easy to use as Raspberry Pi OS is, because some of them don't make it so easy. Alex, what level of PC game do you think will be achievable? Like, how old of a game or how new of a game do you think people will be able to play on the Pi?
So this is the thing. I once again, I have to make the warning that this is something that I haven't tested myself. But the advantage that appears to be on Windows for ARM is that Microsoft already has an ARM to x86 emulation layer there for 32-bit. And they announced recently that they're going to do a 64-bit version of it. So I have been getting people in my Discord community that are trying this, sending me screenshots of, hey, here's Half-Life 2 working, here's Portal working. And I'm like, what? That shouldn't be happening. That shouldn't be possible. But I see the screenshots and I wonder myself just like how bad or just how passable it can get working on at least low resolutions. So if that's the results that are happening right now, I'm just very curious about what could be done. If I have seen some very small progress on stuff like Half-Life 2, I do wonder if we can get like Portal running like decently well, because that for a computer that size, that will already be like an outstanding achievement. And just if that's like acceptable performance, then anything older than that, that there's a very rich history of PC games beneath that line that could just work very well. And I will imagine, see, like some people are evidently already trying this. Like I keep getting screenshots of it.
I don't know if he's kidding or not. He says he got Portal running at 35 FPS on Pi. Well, that's really cool. When we had Evan Upton on for our first episode, he said he thinks that Pi gaming should be a bigger thing, that more people should be talking about gaming on Pi and developing games for Pi, not just doing emulation. So that's really impressive. I kind of want to play some of my old school, really old PC games from back when I was younger on the Pi. I want to play like original Wolfenstein or something, but that's probably not that big a deal for it to run.
Morrowind. We need Morrowind.
Yes, I was thinking that. I was thinking that sort of generation. It's interesting to me because there's so many projects out there of people making like, oh, here's a mini Super Nintendo, here's a mini Game Boy, like that. There's like an industry already of accessories for the kind of stuff, and I do hope that either Box86 or actually it could be both Box86 and Windows on ARM become mature enough that we could get like, hey, here's a miniature like Windows XP PC that you can play games from that era that is actually running a Raspberry Pi. Because I think that's the same way we get like mini retro consoles. I would love to have a mini retro PC that I could just plug into something, my mouse and keyboard, and play there.
I would love that. That would be awesome. So speaking of awesome things, Ash, you have an amazing 3D printing technology you want to show that involves the Pi.
I do. I want to show off something called Octoprint. One thing I've noticed that I find interesting is that 3D printing goes with the Raspberry Pi community like peanut butter and jelly. For some reason, there's so many people who have both a Pi and a 3D printer, and this project is like merging both of those things together. So what Octoprint is an open source, I think it's open source. It's an application for the Raspberry Pi. It's a single image that you have to install onto an SD card, or actually I think you can install it on top of Raspberry Pi OS through Python, or not through Python, but through Terminal. But you install it onto the SD card, load it up, connect it to your 3D printer, and you can use your browser window to control your 3D printer through the Raspberry Pi. And because it's in a browser window, you can access it using your cell phone. So I've got it set up here with a Prusa Mini at my house, and I'm going to switch my camera feed over. And what you can see on the screen here, there's a temperature chart. And the red line represents the temperature of the nozzle. The blue line is the temperature of the bed. You can adjust the temperature just on the spot right now. Like maybe I want to lower that to 204. It'll start to immediately drop and it'll show you the changes in real time. You can send files to print from your computer directly. So you don't have to get up with a flash drive and walk over to the printer, plug it in. You can just drag and drop everything here in the window. I have a camera connected, a Raspberry Pi cam, and through this control tab, I can get a live feed of my printer. And using my keyboard, I can even do things like control you can see the nozzle scooting over. I can control the X, Y, and Z axes here. I can scoot my little Benchy boat up and back. And there's all sorts of add-ons too. One of the biggest draws, I think, is the add-ons that you can have. There's one called Spaghetti Detective, and it'll tap into the camera feed and keep an eye on your print. And if it notices a print is failing and shooting, filament everywhere, if it detects your spaghetti, it'll automatically turn off your print. So like I said, once you get used to using a 3D printer with Octoprint, it's really hard to go back to not using it, because it opens up your 3D printer to like a whole new level of control, and it's really fun.
That is really awesome. Does it work with every 3D printer?
It works with a lot of 3D printers. I think it has to be running a specific version of Marlin, but if you want to know if it's compatible, go online, look up Octoprint with your printer model, and you'll likely find something. Avram, you were talking earlier about pushing the boundaries of what you can do, whether or not you're supposed to do it. Technically, the Prusa Mini is not officially supported, but as you can see, I was able to get it working. So even if your printer isn't officially supported, you can find some steps online and do a little tweaking and probably get it running.
Here at Tom's Hardware, we laugh at the idea of officially supported. Can you make it happen or not? We don't
Exactly.
like officially supported. We like to try and find things that are not supported and make them supported. So, Les, you had something really cool that you were going to show also.
I was, and in the grand scheme of things, all I can show you tonight is failure, because two things have happened tonight. One, my overhead camera, which is actually a Raspberry Pi 3A Plus, has died completely. It is not sending any video. So I tried to reboot it 3 times while I've been on this call tonight, and it hasn't worked. So I thought, that's no problem. I can just switch over to the other demo I had. And yeah, that has died as well. I was going to show you tonight Node-RED, which is a way of programming the Raspberry Pi and other machines using nodes that join together to form a flow. So think of it as Scratch, but for adults. So you put all these blocks together and you have these messages and flows that stream across. And you can create some really wonderful things. And I have an Explorer hat in front of me. There it is, with a potentiometer wired up to the analog inputs. And I was going to show live the voltage levels from that potentiometer to the analog input, so you could see on a graph how the voltage changes over time. Unfortunately, it decided to crash at the same time as the overhead camera, so I'm thinking there's something wrong with my network somewhere for these two Pis. But, we live and learn. I've had a fail. I've learned that I need to fix this, and I'll get it fixed for next time.
This is the dark side of working in the unsupported area.
Yes. So
Yeah.
I have something cool I wanted to show folks, which is something you can read about on Tom's Hardware. Simple facial recognition with Raspberry Pi. Now, a lot of folks have found tutorials that will show you how to do recognize a face, any face. But what fun is that? Because then it can't do different things for different people. Well, one of our writers, Caroline Dunn, whom we've had on the show before, just published on our site facial recognition tutorial that makes it really, with some code that makes it really easy to do facial recognition, to train for particular faces. So I'm going to share my screen here and show you just how it works. So let's see. Okay. So over here I have, presumably we've already downloaded the software from Git, and in the facial recognition, there is a folder called HomePi facial_recognition dataset. And there you create a folder for each person by name. I've just created a new one for myself called Abram2 because I have other ones in there from before. There's a Python file called headshots.py, and you need to replace where the name is in the file with the name of your new folder. Then what you do is you launch this, and it's going to let you take photos of yourself. Let's see if that happens. Yes, it just takes a few seconds. There we are. So you look at this, and you hit the space bar a few times, and it's going to take pictures of you. You do this about 10, 15 times. Try to get your face in a better position than I'm in right now, looking up at this, and do different expressions, maybe with and without glasses, and 10, 15 times. After you do that, you go to the terminal and you go into the facial recognition folder and you run Python train model.py, and it will go through all of the photos for all the different people, and it'll train for them. And that takes a few minutes, so I'm not going to do that while we're demoing. I'll show you the end result. So the end result is we have this program here called facial recognition. And if I run that, you will give it a second to fire up. You will see that it will draw a box around my face and show my name. And if there is, for a second there was showing my son's name, but most part this is pretty accurate. And you see it'll show my name, it'll draw a box around my face and show my name. And that's even where I'm wearing a hat, and I trained it without a hat.
And glasses.
I trained it with my glasses on, but it also has worked with my glasses off. So it works reasonably well. And then there's another part of this where we have an email script where you can have it email you what person has appeared. Now, that in and of itself might not be that interesting. If you see the terminal here, those who are watching see it sort of shows the name of the person it detected. It sort of falsely detected my son Isaac on here a couple times, but it's actually been pretty accurate. So if you take that email script and which here is a facial rec email script, and you modify it, you could undoubtedly make it do something other than email. I'm sure you could make it do something like move a robot, or light up a light, or use text-to-speech to give a greeting. So there's a lot that one can do once you know who it is and you've trained for it. Also, you can use, and we have this in our tutorial, you can use photos to train, not just taking pictures while you have it open. So you could take someone who's not in your family or your friends or whatever, and who's not been on the capture, and feed them in and have it know them as well. So object recognition is obviously really cool, cutting edge, because that's what people want to do with a lot of their projects, is do something different for different faces, different objects. And this actually works pretty well. I mean, I'm not going to say it's getting like 30 FPS, but you could see that it wasn't, perhaps you could see, considering I was going over VNC and over streaming, that it was actually not that jerky at all, and pretty lag free. So anyhow, I want to thank our guests, Alex from LowSpecGamer and Jeff Geerling. As always, thanks to everyone who watched live and watches and listens after the fact. We are here every Tuesday at 2:30 p.m. Eastern, 7:30 p.m. BST. And we look forward to talking to you next week. Bye, everyone.